right, you have had a couple minutes to work on this exponential function and figure out what the equation is. Do we have any takers? Do you think they have it? Well, there are two ways to do it. We can use, and I heard some of you say, stat calc. Yes, you can put this in a calculator, stat calc, and enter this column for L1 and this column for L2. And then if you want to calculate an exponential function, you can do that. In fact, if I had a calculator, that's the way I would do it. But before we broke for midterms, we used to do exponentials. We should say our equation is some value times another value raised to the power of x. Our variable is the exponent. That's why we call it an exponential, right? So, can anybody remember what the a stood for? That's our starting number. Where do we find it on our table? So 0. Yeah, it's what's across from 0. That's our a value right there. Boom, half done. Now, when it came to exponentials, we talk about growth and decay, right? So it was either 1 plus or minus, right, our rate. And if we were subtracting our rate, it would be less than 1. If we were adding our rate, it would be more than 1. If I'm looking at this table right here, do you think I'm going to have a plus or minus?
Plus.
Why do you say that?
Because the numbers increase.
The numbers increase. You guys, someone's here, right? Good. No, this is increasing. As I go down this amount column, my numbers are going up. If you ever put your money in a bank, and you're like, here, in 10 years, how much do I have if I can get 1,000? If they're like, you'll have $723. Don't put your money in the bank. There's rates, and it should go up if you don't touch it. Okay? So, how can I figure out? That's good. It's going up. This is 1 plus your rates. But how can I figure out, without going to stat edit, and you can use a calculator, but how can I figure out the rates? Back to 9th grade, maybe 8th grade for some of you guys. If I have two values, and that rate increases, I take the change of my value, that's what the triangle means, over the beginning amounts. So that would be 35 over, what was the beginning amount? If I put 35 over 500 in the calculator and hit enter, what do I get? 0.07. That's your rate. How much? What is that in percent? That's 7%. So we put 7% in here in our equation. We put 0.07. We put 0.07 because there is no percent button in our calculator. And if I wanted to combine that, I could, but that's your equation right there. That's it. If I could stat edit, and I put all those years in L1, and all the amounts in L2, and then stat calc and an exponential regression, it would give me 500 times 1.07 to the x. Oh, your favorite. The first class did it, they gave me that.
Hey, you gotta round it out though.
It would be closer to the penny. Why is that? Because pennies here get cut off for 2 decimal places. The calculator doesn't know you're using money, so it just gives you longer decimals. Okay? So yes, it might be slightly off, but that's what it should get. All right? So, when they ask us what's our equation, well, we can answer that now. Our equation, because we're good, is 500 times 1.07 the x. That's the first part. That is the equation we answered. So now, there's actually a second question there. How much will you have in 10 years? Where would you put the 10 years? Where would you put the 10?
Oh, the x.
For the x. Because isn't that x, that represents our time, really? Really, I should put an n there, because there's an n here. I should have, but I wouldn't take points off and put an x. It's still an exponential equation, and it still represents our table. So we're still good. So this is our time. This is our years. So that's where our exponent is. So someone tell me.
It's
1.07 to the 10, right? He said it's 983 point what? What's after the 6?
Oh, no, give you all of them?
No, I wanted money. I should have round.
Oh, I mean, it's 5.8.
58. Okay, that's my first class told me. So if they would have lied, I would have been really upset. There you go. $983.58. That's what we get after 10 years. No, well, think about it. It's $500. They're not gonna, 7% you don't get in banks anymore. You get like 3%. But what happens if we put $5,000 in here instead of 500? Add a zero. Well, now the decimal slides. I have almost 10,000. So the more money you have, the more you make. If I give you 10% on $10, you get $1. If I give him 10% on $100, he gets $10. So what you have matters when it comes to interest. Okay, that's why saving your money is important. Next question: how long will it take you to double your money? What do we start with? 500. What do we have it for 10 years? Okay, well, what's double 500? So, I mean, it would be close to 10 years. Would it be a little bit before or a little bit after? A little bit after. If you try to figure this out and come up with 7 years, you did something wrong. You should know that, okay? So, here we go. We're going to use our, we're still going to use the equation we came up with.
So you put 1,000 for X,
Thank you. Okay, 500 times 1.07. They want to know the time. They want to know what the exponent is for your money to double. Okay, if you start with 500, double is absolutely 1,000. Tell me what I do. Am I adding 500 to the right side? Why would I subtract? Because I'm adding 500 to the opposite math?
Oh, no.
Thank you. I divide. I divide 500 from both sides, and watch what happens. This will start to make sense as we do this. You get 2. Why do you think we get 2 here? Because we're doubling. If we're tripling it, wouldn't it equal 1,500? Because that's triple 500. When you divide, you get a 3. I mean, so it should make sense to work through it. 1.07 to the x. Now, my friends, how do we solve for that x? Stop it. See that? Right back there, that little figure there with all that ketchup on his face. Was it? Yes. Yes. And then here, but you're right. Logs are natural logs. That brings the exponent down, doesn't it? I know we did that like a week ago before midterms, but now this is what I use log, use natural log. I know if there's an ES, use natural log. What? Use natural log all the time if you're unsure. Use natural log all the time if you're unsure. It'll work the same as log does. So if I take the natural log of both sides, my exponent becomes a lead coefficient. So I now have the natural log of 2 equals x times the natural log of 1.07. What do I do to get the x alone? Thank you. Divide by the natural log of 1.07. And in your calculator, it is. So give me 3 decimal places. So x is going to equal 10. 45? 10.245, and that's in years, right? So, obviously, we would say it would take approximately 10 years. If you're talking bank, you want to say it's going to take you 10 and a quarter. That's almost 0.25, which is a quarter. 10 years, 3 months, whatever. It would say approximately 10 years. We can check that in the calculator, can't we? For all you out there who did stat edit, and we should put our equation. In our y1. That's where it is. Now, if I were to look at my table, let me go to table set here. Let's start at 0 and go by 1s. Look at my table. Well, isn't that what it started with? 500. The second one was 535. Absolutely. So if we go all the way down to 10, let's see if we're right with that first. Yeah, right there. 983.58. Perfect. Now, if we go to 11. Obviously, it's somewhere between 10 and 11, and we came up with 10.25. We want to get even crazier. We can start at 10, and we can change it by 0.1 instead of 1, so we can see the decimals in between 10 and 11. And that isn't going to take me too long. And where is it? Between 10.2 and 10.3. See that? And we came up with 10.almost 25, which is right between 10.2 and 10.3. Wow, craziness. Now, I know. Now, I don't like throwing this at you because it is not written in normal sentences. It is written in math sentences. But when you go to college, you're going to get textbooks, and they're going to explain things just like you see under the amounts in the account here. It's A and 0, and it gets crazy. Okay? But let me really break this down for you, what it means. It's not hard at all. Suppose you have P dollars that are invested in an account that pays an interest rate R at the end of the year. That's all fine and dandy. But they say A sub 0 equals P, which is our principal amount. What is our principal amount back here? It was 500, wasn't it?
Yeah.
So really, this is just really our A value. This isn't anything new. I mean, if you can put that together, okay, yeah, that's really our A value. So that should be scary. Okay. But look what they do next. After year 1, they take your principal, which is your A value, right? Okay, and they add P times R, and say, well, basically when I do that, I take your principal, then I figure out the rate of that principal, and I add it. That's what you do. So if you have $100, I'll give you 10%. Well, you take your $100, then you figure out, well, what's 10% of 100, and I add them together. And all they tell you is that you come up with this right here. Okay? That is our principal value times 1 plus R. What is the exponent outside that parenthesis? It's not written there. Stop it in this situation. If it's not written there, it's 1. So the first year, P times 1 plus R raised to the first. Huh. That's interesting. Where in God's name have we seen that before? Curious. Let's take it another step further. A2. You take what A1 is. What's A1? It's this. And you multiply it. You multiply it times another 1 plus R. Let me rewrite that. I take my A1, which is P times 1 plus R, right? That's what A1 is. And I multiply it times another 1 plus R. What happens when I have something multiplied by itself? How else can I write it? Square it. 5 times 5, I can write 5 squared. So can I write this as P times 1 plus R squared? Yeah. For A2? Oh my God, look at that. And they write it out this way. So guess what? After 3 years, guess what happens? Why? Because I take A2, which is this, and I multiply it times another 1 plus R. Now I have 3 of them. That's all you do. So that's how your textbooks will explain it to you. They're going to expect you to kind of decide that if you need to. Like I said, I almost took this out of the slides because it's kind of crazy, but I want to expose you guys to this. Okay? So, basically, now that I explained that to you, if my time is not a number, it's now an n, what do you think the equation is going to look like? If my time in years is n, a variable now instead of a number, what do you think is going to happen here? The exponent's going to change there. And that's what we use. And that's what we explain in college textbooks like this, where there is no ELA, there is only math involved. And that's how it goes. So anytime that they want you to figure out money in a bank account where it's just annual rate, which means once a year, that's the equation you're using. That's the equation you're using. That looks familiar, it should. Remember how we did the bacteria and the petri dish thing? And we did the jobs. Remember how we did Detroit, the population was shrinking because of the car industry. And then in California and Silicon Valley, it was increasing population. Why? Yeah, there's more jobs out there. And Rochester was decreasing. Didn't we use this, which was population growth? Well, guess what? Look at that. It's the same thing. Money works the same way. Okay? So we see that if it's compounded yearly, which is once a year, that's what you use. But that's what the next question says. compounded more frequently, then what happens? Okay. So, what would be more frequently than once a year? Okay. Which is biannual or semi-annual, which would be twice a year. What if I said every 3 months? What would that be? Quarterly, because a quarter of a year is 3 months. That throws everybody off. They see 3 months and they make it 3. No, it's 4. It's 4 times a year, every 3 months. Okay. So, you ready? Suppose we compound it more frequently than once at the end of the year. What do you think should happen? You ready? Don't freak out. There's one letter that's different here. What is it? K. A K gets introduced. You put it under your R, and you multiply it times your T, the same number. And what do you think K represents? Almost. The number of times compounded per year. Number of times compounded per year. Okay? So if it's semi-annually or biannually, what's your K value? 2. So a 2 would go under your R, and you multiply your T times 2. If it was compounded quarterly, what's your K? 4. So a 4 would go under your R, and a 4 would multiply times your T.
So when you see how those times
No, so let's say it's 5 years, but it's compounded quarterly. 4 times 5. It's a good question. So let's take a look back at this. If it's annually, what's the difference here? Okay, we have P times 1 plus R over K, KT. What if it's once a year? What's my K value? It's 1, isn't it? You pay attention? If it's compounded yearly, your K will be 1. What happens here? 1. What happens here? 1. What's 1 times T? What's R divided by 1? It's still the same thing. You can still use a K value. It's just they just take it out for you. So it's not too crazy. You can really use this for everything, even annually. You just put a 1 there for K. All right? Thank you. You ready for this? Let's apply it. Let's apply it. Suppose Mr. Visca invests $500 at 9% annual interest, compounded monthly. What's your K value? 12. That means compounded 12 times a year.
That's high.
No, when it comes to money. You keep on giving me more and more money. The more times you give me more money, I'll take it. Yeah, you don't get, it would be nice to get 9% per share. Okay, so how much would his investment be 5 years later? Okay, so we've got to figure out 5 years later, compounded monthly, okay, starting at $500 at 9% interest rate. And then how long will it take Mr. Visca's investment to grow $300? So we can find the first one out real easy. Just plug it into the calculator. What did I say?
300.
Oh, man. And there's no way for me to go back and edit that either. Dang it. Okay? 3,000, right? So we're going to answer the first question 5 years later. Simple. The second question, I want you to figure out algebraically. They want you to figure out the time to get to 3,000. Not 300. 3,000. 1 to 300 versus this whatever game. Okay? Who can tell me how to do this first one here? How much would it take to be 5 years later? How about I start that? Yeah. So what's what here?
So 500 is repeat.
Okay, this is our starting, and then, sorry, what did you say? K is 12. R is 9. Anybody else?
5 years. T.
Nice. T. And really, what do we have? 1, 2, 3, 4 variables. And what do we need here? 1, 2, 3 is a K, 4 is a T. I mean, you have enough to figure it out. Why don't you guys take a minute to figure it out? Okay, let's go. So, anybody besides 1.9? What do we have?
782.84.
Yeah. 782.84 is what we're saying for the first one.
I just want to know because that wasn't my answer.
Okay. 500s are starting. 1 plus our R, which is 0.09. Our rate should be in decimal. Let's not forget. Over 12, which is our K value. K times T, 12 times 5. If I put that in the calculator just as it is. All right? Just as it is. Let's make sure you guys got the same thing. 500. Like I said, I would put this exactly in just like it's given to you. Let the calculator do all the work. Raised to the 12 times 5. Yeah? 782.84. 782.84. It's good. If you got the calculator, it'll do the work for you. All right? Now, how long will it take? What variable will I have to solve for when they say how long will it take? Time, which is what position? Okay. And so the 5 is which is the exponent. We have to solve for an exponent. 4 to get to 3,000. Now, I want it to equal 3,000, right? My p is still the same. 1 plus 0.09 over 12 is still the same. 12 times 2. That's what I'm finding right there. To make things easier for you, I would combine what's in parentheses first. And as long as it's going to run on decimal, it'll be easier to work. Someone tell me, what do I get when I add 1 plus 0.09 divided by 12?
You get 1.0075.
That's exactly right. 0075. And that's raised to the 12. See, that's going to make things easier. And you're still multiplying that times 500. It still equals 3,000. First step. Well, it doesn't matter. After you combine that, you can apply the extra. We'll divide by 500. Absolutely. What is 3,000 divided by 500? 6. Hope you guys know it. You probably shouldn't have used a calculator for that. 5 is in the 36 times. Crazy. How do I solve for that?
Natural log.
Thank you. You need to use a log. You got to bring that down. So I take the natural log of one side. Do it to the other side. So I have the ln of 6 equals what?
ln of 6 equals 12t.
Thank you. 12t times the ln of 1.0075. Now, if I'm going to divide here, I can't just divide by 1.0075. I cannot divide just by ln. It's like a square root. If I have a square root of 7, I can divide by the square root separately and divide by the 7. They're combined, forever conjoined. So how do we get a t alone?
You divide by the natural log of 1.0075.
So, yeah, because aren't you multiplying t by that?
Yes, you are.
So guess what? Instead of taking 2 steps to do something, why don't I do everything in 1 step? What else can I do here?
So,
Thank you. The t is being multiplied by my natural log, and it's being multiplied by 12. So why don't I divide by both? Just like I can divide by both here. Gone, gone in 1 step. My t is approximately, I don't know, 1 decimal place. What do we got? Put that in the calculator. Let me know what you got. Sorry. Put it in there. Let me know what you got. Is she right? I don't know if she's right or not. You tell me.
you said what?
What I wrote on the board.
Yeah, I got that.
Okay. So, if you were a banker, what would you tell me? You would tell me 19.98 years? You say it's approximately 20 years.
20 years.
So you say approximately.
So it's 9%.
And 9%.
20 years?
Well, if you want to have your money multiplied by 600% growth. Yeah, and you don't get 9% things.
That's crazy.
And then I'm going to show you one more thing and we'll be done. It's like this. I have $500. Invest it and I want my money to double in 10 years. What interest rates, compounded annually, do I have to find? So now I got to find the interest rates. I need to find the interest rates, and if it's compounded annually, do I need the K?
Oh.
I can use a K, but it's going to be a 1, which means it'll go away, won't it? K times T, if it's 1, will just be T, wouldn't it? This is what I'm trying to find. Okay, what's my principal value? What is is, well, we have our rate we're trying to find out.
T is 10.
T is 10, that's time.
And now your f of x.
What's our f of x?
1,000.
Our f of x is doubling. That should be 1,000. Okay? So how do I write that equation?
1,000 equals 5 plus r raised to t. How many 10 years?
Raised to t, which is 10. I mean, if you want to use the k, you can. All that I'm doing is I divide this by k, which would be 1, and I multiply 10 by 1, which is still 10. I mean, you can do that, but why do that if you don't have to? Now, first thing I need to do.
You gotta find your range.
Well, yes, but in order to do that, the first thing I do will be to divide. What do I have on the left now? 2 equals 1 plus r all of the 10. Oh, I can't just subtract 1. I got to get rid of the x. What do I do?
ln.
No, that'll bring the 10 down. But then I have the ln of 1 plus r, and I got to get rid of that. Next to an e, which is crazy. If that was squared, how do I get rid of a square? So if it's 10, what do you think I do to get rid of 10? Then 10 through. Who cares? Calculator can do that for you. So if I put this to the 10th root, this will cancel with this, and I do it to this side as well, right? So I now have the 10th root of 2 equals 1 plus r. How do I get r alone? I subtract 1 from it. So when I subtract 1 from both sides, I have, all right, follow me here. The 10th root of 2 minus 1 equals r. So you tell me, give me 2 decimal places. So that will be after you convert it to a percent. Now, I am going to show you right now. Don't everybody, freak out on me here. All right, clear. I like to put the root first. So this 10th root, I put 10. If I don't, I'll take my previous answer. I'll explain in a second. And then I hit the math button. And then see what number 5 does? Whatever number you just typed will go up where the x is. So I press that, look at that. Now look, here's the big mistake everybody makes. 2 minus 1. Why is that wrong? Yes, thank you. That minus 1 is not under the radical, so as soon as I pop out, the radical stops. Minus 1, what'd you get? Yeah, 7%, so 7 point what percent? 2 decimal places after. So in order to turn this into percent, 7.1 and round up. This is 5 or higher, that round up. 7.18%, okay? 7.18%. That's compounded annually. Let's find out semi-annually, but once we do semi-annually, you can do the rest without even doing any work. No. No. Semi-annually, everything's still the same. We still have our 1,000. It's still going to equal 500. 1 plus rights. We're figuring out our rates divided by our k value. What is our k value that is semi-annually? It's twice a year, isn't it? So k would be 2. 2, which means I multiply my 2k value times t, which is 10. Guess what? If I divide both sides by 500, I still get 2. 2 equals 1 plus r over 2. What is 2 times 10 to the exponent? It's 20. Now what do? I have to take the 20. Who cares if it says 7,000? Get a calculator to do it. Look at 20th root, which means I take the 20th root here. Oh, you figures. So the 20th root of 2 equals 1 plus r over 2. What do I do next? Minus 1. There you go. So I've got the 20th root of 2 minus 1 equals r over 2. And Don, you said do what?
Multiply by 2.
And multiply times 2. This whole thing times 2. In the calculator, that's what I put. Give me that decimal, or give me that percentage, 2 decimal places. I'm just trying to cram this in. What do we got? 7? Going what? 0.05%. That's what you get when you put this in the calculator, just like this. Guess what? How come when I say if it's compounded quarterly, I don't have to redo all that work? What is going to change if I compound that quarterly? Well, wouldn't my k value change? Here and here?
That'd be 4.
So a 4 would be outside. And what else would change?
Oh, that'd be 40.
Yeah, 2 times 10, it would be 4 times 10, it'd be 40. That's all you do for quarterly.
40.
And if I could compound monthly, well, a 12 would be outside, and it would be 12 times 10. It'd be
120.
Yeah, so we don't have to do that, and I won't let you guys off the hook on that, because I want to show you one more thing. So, what should happen to the annual rates as it's compounded more frequently? The percentage gets smaller and smaller, ever so slightly. Because when it's compounded more, you get more, so you don't have to get as big a rate to get your value. By compounding more. You get more money frequently. Okay? Yeah. Now, what if it doesn't say compounded once a year, or twice a year, or what if it says compounded endlessly? Or they might say compounded continuously. You know what you use? This is the easiest one of them all. 8%.
8%.
That's your final amount. Principal. This is the E in the calculator. It's not a number. Well, it is a number, but it's not a number that's going to be given you in the problem. 2.718. This is your rate. That's your time. 8%. That's it. You have homework, okay? You have homework. Page 341. I'm hoping that's right for your textbook. You know, something more slightly different.
Why is it